Hello grade 12s and welcome to this video on aldehydes and ketones. In this video we're going to focus on drawing aldehydes and ketones, and I've decided to include these two homologous series in one video because they have the same general formula, but you will also notice that their functional groups, although different, look similar. When we look at the aldehydes, their functional group is called the formyl group or the formic group. We see that there is a double bond O on one of the carbons, but here this carbon is specifically the first carbon in the aldehyde chain. The name of aldehydes end with a -al. When we look at the ketones, they also contain a double bond O on one of the carbons, but this carbon has at least two other carbon atoms surrounding it. Therefore, this functional group is called the carbonyl group. The way I like to remember it is that A is the first letter of the alphabet. Therefore, for the aldehydes, the double bond O is going to fall onto the first carbon atom in its chain. We're now going to take a look at a few examples from A. Oliphier's textbook on organic chemistry. Here they say draw the structural formulae of the following aldehydes and ketones. Now here we need to pay attention because they have mixed the different homologous series. Number 1, or in the first question, we have 2,3,4,4 tetrachlorobutanol. The name ending with a -al means that we are dealing with aldehydes. The aldehydes have their functional group on the first carbon atom in their chain. But what is the longest chain? Over here, the longest chain is a bute chain, which means that it is made up of 4 carbon atoms. We need to ensure that we draw the functional group on the first carbon atom in this chain. We can either call the carbon on the left-hand side, the far left, the first carbon atom, or the carbon atom on the right-hand side, the first carbon atom. I'm going to call the one on the far right end the first carbon atom, and I therefore draw in the double bond O and then an H on that carbon atom as well. Now we can go and draw in the substituents. Here we have halogen atoms, specifically chlorine atoms, and there are 4 of them indicated by the word tetra. Tetra means 4. There's 1 chlorine atom on carbon 2. Since we are numbering from this side, with this being carbon number 1, we're going to have 1 chlorine atom on carbon number 2. 1 will be on carbon number 3, and we're going to have 2 chlorine atoms on carbon number 4, indicated with 4,4. Now we need to ensure that each of the carbon atoms have made 4 bonds, and to do so we're going to draw in hydrogen atoms where they have not made 4 bonds. It is very important that you be careful when you do so because sometimes we tend to overlook the fact that a double bond is made here and therefore this carbon atom has made 4 bonds. But we have now completed the structural formula of 2,3,4,4 tetrachlorobutanol. We can go on to the second example, 1-iodopropanone. The name here ends with -one, and this is therefore a ketone. We have that the longest chain is a prop or propan chain and therefore contains 3 carbon atoms. We must ensure that we draw the functional group before we do anything else. Remember that when it comes to the ketones, the functional group is always on a carbon atom that is between 2 carbon atoms. We tend to indicate in the name which carbon atom this functional group falls on. But since we are dealing with only 3 carbon atoms, there is only 1 carbon atom, this one at the center, that is between 2 other carbon atoms. And therefore the functional group of this compound will fall on the second carbon. So we draw in a double bond O. Now there is a substituent, specifically iodine, which falls on carbon number 1. Here I'm going to choose to make the carbon on the far left carbon number 1, and therefore I'm going to draw in an iodine atom on this carbon atom. All that is left now is for us to fill in the hydrogen atoms so that each carbon creates 4 bonds. Again, it is very important that you do not overlook the double bond over here, because this carbon at the center does not require any additional atoms because it has already made 4 bonds. And this is the structural formula of 1-iodopropanone or propanone. We're now going to look at the last 2 examples in this video. We're still drawing structural formulae. And here we have 5-bromo 2-ethyl 3-methyl pentanal. The name enal refers to the aldehydes, and the pent tells us that there are 5 carbon atoms in the longest chain. So we start off by drawing the longest chain. Now, just to ensure that you understand that the functional group of the aldehydes always falls onto the first carbon atom, and that we can choose that carbon atom to be either on the far left or on the far right. In this case, I'm going to choose to put make the carbon atom on the left-hand side the first carbon atom, and therefore I draw in the functional group of the aldehyde. Now we need to draw in all of the substituents. On carbon number 3, we have a methyl group. So over here, we're going to draw in a methyl group, which is basically CH3. On carbon number 2, there is an ethyl group. So on this carbon, which is over here, we're going to draw in an ethyl group, which is CH2, and then attached to that a CH3. The ethyl group contains 2 carbon atoms in its chain. Lastly, we have a bromine atom, 5-bromo. So since we are numbering from the left-hand side, making this carbon number 1, we're now going to go ahead and keep counting, and we find that the 5th carbon atom is over here on the right-hand side, and we can attach the bromine atom over there. It's very important that you remember always that the functional group of aldehydes fall on the first carbon. Now that we've drawn in the substituents and the functional group, we can go and ensure that all of the carbon atoms have made 4 bonds and include hydrogens where they have not. And having done so, we have drawn or completed the structural formula of 5-bromo 2-ethyl 3-methyl pentanal. Now we can look at the very last example in this video. It is 4-chloro 3,3-dimethyl 2-pentanone. Again, the longest chain here is pent for 5, and one refers to a ketone. So we start off by drawing the longest chain. Normally, when we name compounds like these, it will be pentan 2-one, but this is also acceptable where they have placed the 2 in front of the pent. And this tells us that the functional group of this ketone falls onto carbon number 2. Again, we could instead call this pentan 2-one, which is what we normally do. I'm going to make the carbon on the far left-hand side, carbon number 1, and therefore the double bond O, the functional group of this pentanone, is going to fall on this carbon. Now we can draw in the substituents. We have 3,3-dimethyl, which means that there are 2 methyl groups on carbon number 3. So we're going to draw those in. We have a CH3 at the top and another CH3 at the bottom. These are the 2 methyl groups. On carbon number 4, again remembering that we are numbering from the left-hand side, on carbon number 4 we're going to have a chlorine atom. So here's carbon number 4, and we draw in chlorine. Now all that is left is for us to ensure that each carbon has made 4 bonds, and where it has not, we include additional hydrogen atoms. And this gives us the structural formula of 4-chloro 3,3-dimethyl 2-pentanone, or we could call it pentan 2-one. This is the end of this video on aldehydes and ketones.